All right, in this review, we're going to be looking at reviewing Chapter 4. So let's start right away with reviewing how to convert from degrees, minutes, and seconds to get an answer in decimal form. So here we have negative 250 degrees, 36 minutes, and 10 seconds. So to get that in decimal form, well, we have the negative 250. So we just got to figure out the rest of it. We just got to figure out what the decimal form would be. So remember, with the 36 minutes, remember there's 60 minutes in an hour. Okay, so if we have 36 minutes, to convert that to hours, or in this case degrees, because they act very similarly, we would divide by 60. So 36 divided by 60 would be 0.6. So we're going to have a 0.6 here. Now we got to convert the 10 degrees, or I'm sorry, 10 seconds. So we have 36 minutes and 10 seconds. So with the 10 seconds, now there's 60 minutes in an hour, and there's 60 seconds in a minute. So in 1 hour, there's 3,600 seconds. So in 1 degree, there'd be 1,000, 1 degree, there would be 3,600 seconds. So we're going to divide this by 3,600. And when you do that, we get 0.003. So when we add that to this, if I add 0.003 to this, we would end up with negative 250.603 would be your answer in degrees, minutes, and seconds. Let's look at the next one. So the next one, we're going to convert that to, we already have it in degrees. Okay, so we have a tenths and a hundredths value there. We just got to convert that to degrees, minutes, and seconds. Now again, with the 94, there's nothing that we have to do there. Okay, so it's 94 degrees. So now we got to convert that 0.72 to be in minutes and seconds. So again, we have 0.72 of a degree. So to figure out what that would be in minutes, again, there's 60 minutes in an hour, and so we have, let's think of it this way, we have 0.72 of an hour. So to figure out how many minutes that would be, we would take 0.72 times 60. And when you do that, you end up getting 43.2. And what we're going to do with that 43.2 is we're going to say, well, there's 43 minutes. And we're going to convert that 0.2 now into seconds. Now again, there's 60 seconds in a minute. So we're going to convert that, figure out how many, so that 0.2 represents 0.2 minutes. So to figure out how many seconds that would be, we would take 0.2 times 60. When you do that, you would end up getting 12 seconds. So this would be 94 degrees, 43 minutes, 12 seconds would be your answer. All right, so this one, let's draw a diagram to help us with this one. It says the angle of elevation of the top of a building from a point 55 feet away from the building is 39 degrees. Determine the height of the building. All right, so to draw a diagram here, say that's our building. It says an angle of elevation of the top of the building 55 feet away, so this would be 55 feet, is 39 degrees. So angle of elevation is, remember, when you look straight out and then look up at the object, so that's our angle of elevation. So our goal is to figure out the height of the building. So this is a right triangle. So we assume that the building is perpendicular to the ground, so it's a right triangle. So we can use that SOHCAHTOA, those trig relationships there, those trig ratios. And remember that the tangent is the opposite over the adjacent, because all I know from 39 degrees is that x is opposite the angle and 55 is adjacent to the angle. So we have to use tangent of 39 degrees equals the opposite over the adjacent. And for this, we just multiply both sides by 55. And when you do that, you get 44.5 feet as your answer. All right, let's look at number 4. So this one, it says the distance from the top of a lighthouse 210 feet away, the angle of depression of a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse. All right, so the lighthouse is 210 feet high. Okay, so we'll say this is the top of the lighthouse. So it's 210 feet high. And then we have some water here. Here's a little boat. And it says the angle of depression of a boat is 27 degrees. So that means when you're looking out here straight out from the top of that lighthouse down to the boat, that angle that's formed is 27 degrees. So it's not that angle. That is not the angle that we're looking at. The angle of depression will be looking straight out from the top of the lighthouse down to the boat. That angle would be 27 degrees. So remember, alternate interior angles tells us this angle is also going to be 27 degrees. We're trying to find the distance the boat is from lighthouse. So again, this would be a right triangle. And we'd have to use a tangent again. So remember to find tangent is the opposite over the adjacent. So it'd be 210 over the adjacent leg, which is x. So remember the long way to do this would be to multiply both sides by x and divide by 10 tangent of 27 degrees. Otherwise, remember we could just switch these two. So we take 210 divided by the tangent of 27 degrees. When you do that on your calculator, again, make sure your calculator's in degrees right now. We haven't worked with radians. These are all in degrees. You end up getting 412.15 feet. All right, so this one, it says a plane leaves an airport and travels 2 hours along a bearing of 120 degrees at 175 miles per hour. It then turns and travels at a bearing of 30 degrees for 2.5 hours at 200 miles per hour. How far from the airport is it from its last position? What is the heading to the airport? All right, so there's a couple things we need to do here. First, you absolutely obviously need to draw a diagram. So let's start with the fact that it's going to travel 2 hours at 175 miles per hour. Okay, so for that distance, we'll get to that in a minute, but we're going to have to remember that we're not traveling 175 miles, we're not traveling 2 hours, we're combining those to get our distance. Remember, distance is rate times time. So let's start with a bearing of 120 degrees. So I'm just going to make this little plus sign here, represents your north, south, east, and west. And 120 degrees, remember we measure from north, 120 degrees would be maybe about here. So that represents 120 degrees right there. And then we're going to travel, again, for 2 hours at a speed of 175 miles per hour. So 2 times 175 is, that's a times, not a decimal. There we go. That would be 350 miles is how far they're going to travel in those 2 hours. And then once we get to this spot, they're going to stop and they're going to turn again. It turns and travels at a bearing of 30 degrees. Okay, so again, measuring from north, this is north, maybe this is 30 degrees here. For 2.5 hours at 200 miles per hour. Okay, make that a little longer, but for 2.5 hours times 200 miles per hour, that means that in that time they travel 500 miles. Okay, so that's important. All right, so here's what we're trying to find. Trying to find how far from the airport is it from its last position, and what is the heading to the airport. Oops. So remember, this is what we're trying to find, and we're also trying to find the heading or the bearing from the airport to that new location. All right, let's see what we can do to figure out some angle measurements here. Use a different color because we're going to get to adding a lot of numbers to what we had. So what's in red is what we had originally. So originally we see that angle 120 degrees. That means that this angle here would be 60 degrees. Okay, so then that would form a 180 degree angle. Why is that important? Well, remember we have this north-south line and this north-south line are parallel to each other. With that line there, that diagonal, that represents the 350 miles as a transversal. So that means these two angles would be alternate interior angles. That's also 60 degrees. So what that tells me is that we have a right triangle. So if we have a right triangle, that opens up the opportunity for us to use Pythagorean theorem, right triangle trig, whatever we need to use to be able to find that missing length. So right now I know that I have a right triangle. Okay, so if I redraw this out, we have a right triangle with this being 350 miles, this being 500 miles, and we're trying to find this distance. So we can use, again, the Pythagorean theorem. So to find x, that's your hypotenuse, would be x squared equals a squared plus b squared. So I'll just tell you, because you guys know the math, you would square those, add those together, take the square root of it. You end up getting 610.3. So that's the distance. That's the first thing that we needed to find, was the distance there. Now the other thing we need to find is the angle. My goal is to figure out that angle right there. Well, the problem is that's outside the triangle, so I'm going to have to do a little bit of work. First, it'd be really helpful if I knew this angle here. And there's enough information for us to be able to find that angle because we know it's a right triangle. So if we find that angle, I could subtract that from 120, and that would give us our heading or our bearing to the airport. So let's see what we need to do. So on this triangle, I know all three sides now. I know that the hypotenuse is 610.3. I know that the other two sides are 350 and 500. Since those don't have decimals and those were values that were more precise, I'm going to use those two sides. And so this would be opposite. The 500 would be opposite. This would be adjacent. So again, we're going to use a tangent. So to find theta would be the inverse tangent of the opposite over adjacent. Again, making sure that my calculator is in degree mode. When I do that, I get 55 degrees. So that tells me that that angle is 55 degrees. Well, remember, the entire angle there is 120 degrees. Okay, so remember that what they gave us was 120 degrees. Well, we found this much of it. So if I take 120 minus 55 degrees, I end up getting 65 degrees. So our bearing or our heading would be 65 degrees. Or remember, you could say 65 degrees east of north, because that would be another way that you could describe it. All right, let's look at this next one, number 6. It says find one positive and one negative angle that are coterminal with 3 pi over 4. Coterminal just means that it's going to give us the same value. So remember that basically there's just a simple formula we could use here, where we take 3 pi over 4 plus 2 pi, and that would give us a value at the same location. Now remember, the way that our rotations work is theta. When theta is positive, it goes counterclockwise. When it's negative, we go clockwise. So if I want to find another value that would end up at 3 pi over 4, I could take 3 pi over 4 minus 2 pi. Now to find those values, we're going to have to combine fractions, and so I want to change that 2 pi, the same as 8 pi over 4 for both of those. When I simplify this first one, I get 11 pi over 4. And when I simplify the second one, 3 pi minus 8 pi, that would be negative 5 pi, so this would be negative 5 pi over 4. So those would be one positive and one negative angle that are coterminal with 3 pi over 4. All right, these first three are just a matter of knowing the unit circle. Then the last one, we have to do a little bit of work there. So remember, on the unit circle, that's actually pretty good. On the unit circle, 3 pi over 4, if we divide this circle up into fourths, where this would be 1/4 pi, 2/4 pi, 3/4 pi would be right here. So remember, at that location is where both sine and cosine are square root of 2 over 2. But remember, in quadrant 2, that's where cosine, or the x, would be negative, but the y or the sine would be positive. So since I'm trying to find the cosine of that value, we would have a positive square root of 2 over, negative square root of 2 over 2. All right, now let's think about if we change this this unit circle to be in 6. So we'll say this is 1/6, 2/6, which would be the same as 1/3. 3/6 would be the same as 1/2 here. Then we would have 4/6, 5/6, 6/6 would be here. Now we would have 7/6, but remember we're dealing with negative 7 pi over 6. We'll get to that in a second. So 7/6, 8/6, which reduces to 4/3. But then we would have 9/6, which reduces to 3/2. Then 10/6, that obviously reduces. Then this would be 11/6, and then 12/6 brings us back to the beginning. Okay, so we've just broke this up into sixths. So again, I want to go at negative 7 pi over 6. So now that's going to be a sixth past pi if we go in the negative direction, or we can count out 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 7. So 7/6 would be right here. Now again, that's where x is positive, y is negative. Or I'm sorry, I said that backwards. X is negative, y is positive. And we also know that at that point, that's going to be where the x, or the cosine, would be square root of 3 over 2, and y would be 1/2. And so since we're trying to find the sine value there, that's going to be a positive 1/2. All right, let's do the tangent of 3 pi over 2. Now remember, I want you to memorize that in the quadrant 1 here, that we have at this spot here, this is where the tangent would be square root of 3. This is where tangent would be 1. This is where tangent is square root of 3 over 3. And at 3 pi over 2, that's down here. So then we have this spot. So this is where, since cosine is 0, y is 1. Sine over cosine, 1 divided by 0 would be 0. But at these two spots, this is where it's undefined. Tangent of 3 pi over 2 would be down here at the bottom, so that's going to be undefined. All right, let's look at the last one here. On the last one, we're going to have to do a little bit of work. So for the beginning here, they ask us to find the cosecant of 7 pi over 3. The cosecant is the reciprocal of the sine function. So if that's reciprocal of the sine function, then if we found the sine value of negative 7 pi over 3, we would just take the reciprocal of it. So let's think about what negative 7 pi over 3 would be. So again, if we look at this in terms of thirds, this would be 1, let's go in the negative direction, this would be negative 1/3, negative 2/3, negative 3/3, negative 4/3, negative 5/3, negative 6/3. Well, that brings us all the way around, so we're going to keep going. So negative 7/3 would be right here. So that's where point D would be. Now remember, at that point, that's where the y value, the sine value, would be square root of 3 over 2. But remember, we're dealing with the cosecant. Cosecant's reciprocal of the sine function. So the reciprocal of square root of 3 over 2 would be 2 over the square root of 3. Oh, and it would be negative because it's down there in quadrant 4. Quadrant 4 is where sine is negative. Well, I got to so that's what this would be. But we just have to rationalize the denominator. So if I multiply the top and bottom by the square root of 3, numerator and the denominator, we get negative 2 square root of 3 over 3 would be your answer. All right, let's look at number 8. Given sine of theta is negative 2/3 and cosine of theta is positive, find the values of the remaining 5 trigonometric functions. Draw the triangle in the appropriate quadrant. All right, so let's think about this for a second. When sine is negative, that happens in quadrants 3 and quadrant 4. Where is cosine positive? Cosine is positive in quadrants 1 and 4. So obviously, since sine is negative in quadrant 4 and cosine is positive in quadrant 4, that's where our triangle would be. So if I just sketch a triangle over here, quadrant 4, so we have a right triangle there. And we know that the sine is negative 2 over 3. So sine, remember, is opposite over the hypotenuse. That means this leg here would be negative 2. The hypotenuse is always going to be positive whenever we draw these triangles. So this would be 3. All right. So now we just need to use right triangle trig to figure out that other side. So x squared plus negative 2 squared, which I'm going to write as 4. It's negative 2. When you square that, would be a positive 4, equals your c squared. So 3 squared is 9. So we get x squared equals 5. So that means that x equals a plus or minus square root of 5. And since our triangle here, the x would be to the right of 0, we know that it's going to be a positive square root of 5. We'll just leave it like that. All right. So to find sine, that was given to us. It's negative 2/3, opposite over hypotenuse. Cosine is adjacent over the hypotenuse. So the adjacent leg would be square root of 5 over the hypotenuse, which is 3. The tangent is opposite over adjacent. So that's going to be negative 2 over the square root of 5. But if we rationalize the denominator, multiply the top and bottom, the numerator and denominator, by square root of 5, we get negative 2 square root of 5 over 5. All right, now be careful. This next one, they're asking for the cotangent. Remember, the cotangent's the reciprocal of the tangent function. And so we're just going to take the reciprocal of what we had at the beginning there to make it easier. The reciprocal of negative 2 over square root of 5 would be negative square root of 5 over 2. And the secant, that's the reciprocal of the cosine function. So the reciprocal of square root of 5 over 3 would be 3 over the square root of 5. Again, rationalize the denominator, and we end up getting 3 square root of 5 over 5. And lastly, these are reciprocals of each other, so this would just be negative 3 over 2. Okay, so this is just going to be remembering our unit circle. Now also, remember that when we're doing these problems, we're taking the inverse cosine, which is the same as the arc cosine. Remember, we talked about having to restrict the domain for some of these. So to restrict the domain for inverse cosine, we have to restrict it to quadrants 1 and 2. I'm not going to go through the lesson as far as why that is. If you want to look back in chapter 4 to review your notes, you can see, or watch the videos for that, you can remember how and why we restrict the domain for these different values. And for the sine and tangent functions, we restrict those domains to be between quadrants 1 and 4. So that would be between negative pi over 2 and pi over 2 is how we reference that in terms of radians. All right. So the inverse cosine is square root of 2 over 2. We're trying to figure out what values for pi that would be. Remember, we're just looking at quadrants 1 and 2. So even though there's a value down here, out where cosine would be positive square root of 2 over 2, we don't care about it because that's not in our restricted domain. So this would just happen at pi over 4 radians. Let's go down to B. Where is the inverse cosine going to be negative 1/2? Again, our restricted. Let's actually be up a little higher. Be restricted between quadrants 1 and 2. So where cosine is negative 1/2 there, that would be at 2 pi over 3. Right, now this next one we're going to do in 2 parts. So we're trying to find the secant of the inverse sine of square root of 3 over 2. So remember, for the inverse sine of square root of 3 over 2, and since that has to be restricted between quadrants 1 and 2, oh, that was a terrible circle, or between quadrants 1 and 4, remember square root of 3 over 2, that happens at the top up there, so that's going to be at pi over 3 radians. And so what we have here is this is the same as the secant of pi over 3 radians. Let's think about what the cosine, because remember the secant is reciprocal of the cosine function. So let's think about what the cosine of pi over 3 radians would be, and then we take the reciprocal of that. So cosine of pi over 3 radians would be 1/2. So that means the secant of pi over 3 would be the reciprocal of that, which would be 2 over 1, or just 2. All right, so going over to letter D here. So again, now the rest of these are going to be in multiple parts. So we're trying to find the inverse tangent of negative square root of 3 over 3. Remember, Negative square root 3 over 3, that would be the same as this one down here, because remember we want to have these three memorized for the tangent function. Square root 3, 1, and then this would be square root 3 over 3. So when it's negative square root 3 over 3, that's going to be down here in quadrant 4. So that's going to be at pi over 6 radians, or we could say, I'm sorry, negative pi over 6 radians. Or if we go this direction, so you'd have this is the same as the sine of negative pi over 6 radians, and the sine of negative pi over 6 radians is negative 1/2. All right, looking at this next one. The next one's asking for the inverse sine, or the arc sine of negative 1. And I can't draw, so my circle's all funky. All right, so at negative 1, that's going to be down here. And so that's right on the line. So the way that we phrase that, though, is that's between negative pi over 2 and pi over 2. The inverse sine of negative 1 would be at negative pi over 2. And the cosine of negative pi over 2, so that would be, well, what's the x value at negative pi over 2? Well, that's 0. So your answer for that would be 0. And the last one on this, for this section here, would be the inverse sine of 5 pi over 6. So remember, the sine of 5 pi over 6 would be 1/2. So we'd be trying to find the inverse sine of 1/2. And so that's going to be at, what your unit circle, that's going to be right down here. And that's going to be at pi over 6 radians. So pi over 6 radians would be your answer for F. All right, so here for number 10, they're asking us to write an equation of the cosine function with all those different features. Now what you want to remember is our standard form, or our form for our sine and cosine functions are the same, except for instead of cosine would have sine. We had to switch between the two, but anyhow we'd have a times the cosine for this one times our b value, times in parentheses x minus h, and then be plus k. So where h and k represents your horizontal and vertical translation, your b represents any stretches that's happening horizontally, your shrinks happening horizontally, and a is representing your vertical stretch and shrinks, which is also our amplitude. So your amplitude, remember, is your a value. So when it says our amplitude is 2, we know our a value equals 2. Our period is pi over 2. Okay, now remember, to find the period, this up here, it's always, the formula for that is it's always 2 pi divided by whatever our b value is. Well, in this case, we know the period is pi over 2. So to figure out what b is, we could cross multiply. If you did that, we'd have 4 pi equals pi times b. Divide both sides by pi, and I would get that b equals 4. So b value equals 4. Our phase shift refers to our horizontal shift. So our h is a negative pi over 8, and then, so this is our h value, and this is our k value. So let's plug this all in to get our equation. So our equation would be y equals our a value, which is 2, times the cosine of our b value, which is 4, times the quantity x minus h. Now x minus negative pi would be x plus pi over 8. And our vertical shift of minus 3, so plus k would be plus negative 3 or minus 3. So that'd be your equation that would have those different features. All right, so this one, I'm not going to worry about the graph so much. I want to make sure that you know how to get all these other pieces. So we're going to label the axes and asymptotes, if any. We're going to state the amplitude, period, phase shift, and vertical shift. All right, because if this is a multiple choice question, if you know all this information, you should be able to identify which graph would be the correct one. All right, so for this one, we know that the a value is negative 3. So that would be, anytime we deal with our a value, we're always going to use the absolute value. So that would be, our amplitude would be 3. Our phase shift means that we're going to go, so we take x, the opposite of what's happening with the x would be pi over 4 radians. We're going to say that it's going to go to the right, pi over 4 radians. The period, so now to do the period, remember the period is 2 pi over b. So since we see that b is 2, be 2 pi over 2, which simplifies to just be pi. So the period is pi. The vertical shift, there is no vertical shift. There's nothing that we're adding, subtracted there, so there is none. Now the next one, if you notice the difference between these two, this one, we had 2 factored out of there. This one, we don't have anything factored out, so we're going to have to factor out between those two terms. I see that both of them have a 1/4 in common, so this will be the same as 1/4 of x plus pi. So that's important for identifying our phase shift and the period. But the amplitude, it's already positive, so our amplitude would just be 2. So to find the period, so again, we would end up taking 2 pi over b. So 2 pi divided by 1/4, if we do keep, change, flip, we would end up with 2 pi times 4 over 1, or 2 pi times 4, which gives us 8 pi. So our period would be 8 pi there. So the phase shift, again, we would look at this one. Don't make the mistake. If this was multiple choice on the test, don't you make the mistake of thinking that the answer would be to the left, pi over 4 radians. That would be wrong. It's actually to the left, pi radians. And the vertical shift is -3, so that's going down 3. All right, looking at C and D here. For the tangent function, there is no amplitude and phase shift for this one. So this one just has a period. It happens, so it's just a basic tangent function. So it repeats itself every pi radians, and there is no vertical shift, so you don't have to worry about that. For the secant function, you can look back at your notes to see what the graph of the secant function looks like. But for that one, there's no amplitude or phase shift for this, and the secant repeats itself for every 2 pi radians. And again, there's no vertical shift either. All right, so for this one, we're trying to solve a trig equation. So we're trying to solve that equation. So to solve for that, we just take the inverse. Remember, the secant is reciprocal of the cosine function. So if we look at this as being 1 over the cosine of theta equals 3.236, then that means that if we take the reciprocal of both sides, you could say that the cosine of theta equals 1 over 3.236, because we took the reciprocal of both sides. So to find theta, we would take the inverse cosine on both sides. And so now when you do that on your calculator, you get your answer of 71.99 degrees. Okay, now remember, for these problems, remember the way that the function works. And by the way, this one, we know that it's supposed to be in degrees because of this, if you're wondering why we're doing this one in degrees. But 71.99 degrees, that's going to be, let's say, right about here. So remember, there's two values, or it's going to be have the same value for theta. So we're trying to figure out what are both solutions, and we've got to go between 0 and negative 360. So we can't say that it's going to be 71.99 degrees and negative 71.99 degrees, because that's not within our interval there. So if I just take, if I know that this is 71.90 degrees, that means that this is the same. So if that's 71.99 degrees less than 360, so if I take 360 minus 71.99, we end up getting 288.01 degrees. All right, so this is the last problem for this chapter 4 review. So looking at this one, make sure that your calculator is going to be in radian mode for this one. How do I know? Because right here it says we're going to have our answer between 0 and 2 pi. So we already have, we don't have to go through all that process like we had to do on the previous one. So to find theta, we're going to do the inverse sine, 0.756. So again, your calculator is just going to give us one solution. So a calculator, when you do this in radians, gives you 8.857 radians. So now let's find the other values. So remember, dealing with sine would be the y values. So 0.857, let's say that's right about here. Oops, well, that'd be right about here. So let's say this is 0.857. To find the other value between 0 and 2 pi, it's going to be the same over here. So that means that this is 0.857 radians. So if I want to figure out what this would be, I'm going to take, because this is pi right here, I'm going to take pi minus 0.857. So having a visual really helps. As far as figuring out, do I subtract it from pi? Do I add it to, subtract it from 2 pi? Do I add it to pi? What do I do with those values? So from here we can see that we would subtract that value from pi to figure out what that value for theta would be. When you do that, you get 2.283 approximately. Again, both of those are in radians. All right, so that is your review of chapter 4.